Before we start to model threaded fasteners, we need to know a little bit of information about how we code or how we organize this. And the way that we're going to talk about threads is through what we call thread notation right here. So if you go to Lowe's or Home Depot and you walk in the hardware aisle, you're going to find rows and rows and rows and rows of these fasteners that have this information. So there's three really big pieces that we need to know. Really, two of them are super useful to us. One of them we don't really care that much about. So the first one, in our case, the 1/2, represents the diameter of our screw or our bolt, our thread, essentially. And really, that's the major diameter. It's the distance from the outside of the thread to the outside of the thread, not the actual body of the piece that we're looking at. And that'll be useful when we model this stuff in Inventor. The least useful thing is what we call the thread description, and that tells us how coarse or how fine those actual threads are. We don't really care about that all that much because we're just going to keep one size, so we don't have to worry about it. But you could see UNC, which means United Nations coarse. You could see UNF, which is United Nations fine. Ultimately, it doesn't matter for us. Now, the big ticket item is that middle guy, and that is the TPI, the threads per inch. So that tells us, if I were to look at this bolt, if I were to measure off 1 inch, there are 13 threads that are hanging out inside that inch. So the more TPI you have, the more threads are going to be hanging out inside 1 inch. And why that's useful to us is we can use it to calculate what we call pitch. So we can figure out how much distance we need between each of those threads. And it's kind of a simple calculation, but it's kind of hard to work through in your head. So think, what is the distance between the threads if there are 13 threads per inch? So think about that, 13 threads per inch. So if I kind of flip that on its head and say, hey, if I have 1 inch and I divide that 13 times, that essentially tells me how big each thread or each pitch is going to be. Right? So I kind of flip that around. I can say, okay, 13 TPI. I can find the reciprocal, and 1 divided by 13, that tells me how big one pitch is. So if I were to do this on Inventor, I would slap in 0.0769238, blah, 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 inches. So let's put that to good use. Let me pull up Inventor real quick. So this is kind of our goal right here. We've got this metal nut right here, and in this case, we have modeled physical threads. There's 2 different ways to approach this. You can create cosmetic threads and you can create true threads. And we're going to do that real quick for you. So as you guys work through this, you're going to be creating your own metal nut. I would highly, highly, highly recommend you turn the visibility on for all of your planes, your axes, and your center point, because we're going to be able to pull different like rotation points when we do this coil. The other thing I would advise you do is when you extrude this guy, and I'm going to extrude this piece right there, kind of in a similar fashion, I would do the symmetric extrude so that we still have that plane chilling out in the middle, just in case we want to use it for whatever reason. Now for cosmetic threads, this is actually super easy. All we need to do is go up in the modify portion of the ribbon and click on thread. Click on the face that we want to be threaded, which is the inside right there, and we just need to select the type. So they've already picked the size, the diameter for us, which is 0.5, and shows up in the designation, and it says 1/2 13 UNC. Now I'm going to actually change this to 20 for math purposes later on, but you're essentially done. Like that is it for cosmetic threads. But the problem is, if I were to slap this into the 3D printer, it would just print out the body of the metal nut itself. So it would not print the threads out. We need to cut those ourselves if we really want that to be useful to us. So that is where the true thread is going to come in. So I'm going to switch my document real quick. So here is how we create true thread. Now for an internal thread, I'm going to kind of make a triangle and extrude it and try to like rotate it all the way through to create those threads. And this is where TPI is going to come in handy. So I'm going to grab that, what is that, XZ plane. I'm going to start a sketch on that guy, and it's going to show me a little top view action. And all I'm going to do is I'm going to make a little triangle that kind of mimics what a thread looks like. So I'm going to hover over here, and I see this line pops up that represents the hole that's going through the metal nut. And I'm going to go to the very, very edge, and I'm just going to start to draw a triangle. And I'll dimension that in a moment. All right, that looks good. So let's dimension it. And this is where the UNC and UNF comes in. I don't really care. Let's just stick with 60 degrees to make our life easier. And this is definitely not right. So this needs to be 30 to make my equilateral triangle look good. Now, here's where it gets a little bit rough. Because we are using 20 as our TPI, we need to figure out what our pitch is. So from the slide that we talked about, remember to go from TPI to pitch, all you need to do is take 1 inch divided by your TPI, and that is your overall pitch. So because it's 1 divided by 20, my pitch is going to be 0.05 inches. And I can say finish sketch. Cool, that looks good. So we have this weird triangle just kind of chilling on the outside of our metal nut. Now let's actually build that. We're kind of extruding that through the piece. And the new technique is with the coil. So 2 things you need for the coil. You need the profile, which is going to be the little triangle that we made right there. But you also need an axis to rotate around. So I'm going to be grabbing this Z-axis right there. So I'm going to click on that guy, and it is modeling exactly what I want. A couple settings we want to change. Yours is probably going to look different. Your pitch is going to be something completely off. So make sure that you change the pitch to match up with the essentially 1 over your TPI. So I have 1 inch divided by 20 because 20 is my TPI. And I also changed my revolution so it doesn't go nuts. Mine was like a really big number. It was like 70, which is too much. And we can see from the preview that's not super great. So let's go, I don't know, let's go 15. I know it's going to be too much, but we'll turn that stuff up. I have add in there, so it's going to add those threads in. I'm going to say okay, and we're good to go. So notice we have the threads that are coiling all the way through our piece, but we have a lot of excess thread that we don't really need. And it's pretty easy to fix. I'm going to go to my right view, and all I'm going to do is I'm going to start a sketch on this plane right here. And I'm just going to grab, let's just grab our line tool right there. And I'm just going to create a little box that I'm just cutting through those threads. I'm going to create a little square like so. Connect those guys there. Do the same thing on this side. I'm just kind of using the line kind of where I'm shaving this off. Don't really care about the shape. I just want it to go away. I'm going to say finish sketch. And then I'm going to extrude remove both of those profiles. So let's see if I go to my ISO view, remove, extrude, maybe I'll do symmetric, and I can bring it out. I just want to make that big enough where all of those extra threads are going to disappear. And if I say okay, then notice how we've got a nice clean little metal nut that has the threads the way we want it.